In this video, I'm going to go over undefined fractions and simplifying them. The first thing I'm going to talk about is undefined. The denominator of a fraction cannot have the value of 0. If the denominator of a fraction is 0, the expression is not a legal fraction because its overall value is undefined. There's no value. So the first thing I'm going to discuss is figuring out how to find the undefined values of a rational expression. Now, first off, rational expressions are just fractions. When they say a rational expression, they're talking about a fraction with x values in it. So these are two rational expressions, and I'm going to find where the values of x make the fractions undefined. And to do that, all you do is set the bottom equal to 0. The top can be 0. It's okay. So remember, 0 over a number is okay, but a number over 0 is not okay. It spells no, so this is not okay, but on is okay. So we only are going to concern ourselves with the bottom. So I'm going to add 5 and add 5, and I get 2x equals 5. Dividing by 2, I find out that x cannot be 5 over 2, or 2.5, whatever you prefer. That value would make this undefined, make the whole entire fraction have an undefined value. Also, what is nice to note is that if you graphed this thing, on the graph, you would see at 2.5, so 2.5, you would see an asymptote because the graph cannot touch that part of the domain. Okay. So I'm going to do it again with this one. I'm going to set the bottom equal to 0, and I'm going to factor this one because it's a trinomial. So x and x, the factors of -7 that add to 6. Well, the factors of 7 are 7 and 1. To get 6, I'm going to have a +7 and a -1. So in this case, there are two values that make the fraction undefined. X cannot be -7, and x cannot be 1. If you plug those in, it would make the bottom equal to 0, which makes the fraction undefined and not a valid fraction. In this part of the video, I'm going to talk about simplifying rational expressions and stating where they're undefined. The easiest thing to do first is finding out where a fraction is undefined. So I'm going to do that first by setting the bottom equal to 0, subtracting 3, and I find out that x cannot be -3. So that's my undefined value. Now that I've figured that out, I can go ahead and simplify. To simplify a rational expression, all you do is factor the top and bottom and see if you can cross anything out. So the top can be factored into x and x with am. So the factors of -3 that add to 2 are 3 and 1 with a +3 and a -1. So what I have is x plus 3 times x minus 1 all over x plus 3. And if you notice, there are two binomials that can be crossed out. And that's x plus 3 and x plus 3, and we are just left with x minus 1. You need to remember that you can only cancel out the same type of polynomials. So because x plus 3 and x plus 3 are binomials and they are exactly the same, we can cross them out. So that being said, you cannot do this. You cannot cross off 4 and 16 and make that 4. Because they are binomials and they are not exactly the same, you have to go ahead and factor before you reduce. Okay, so before I even do that, I'm going to find out where it's undefined by setting the bottom equal to 0 and adding 4. X in this question cannot be 4, so x cannot be 4 is my undefined value. Now what I'm going to do is go ahead and simplify the fraction. To simplify, I'm going to factor the top first by using dots, x plus 4 and x minus 4. That allows me to see that on the top and the bottom, I see x minus 4. So I'm going to cross that off, and I'm just left with x plus 4 as an answer. In my last example, it's a little bit more complex. To find out where my fraction is undefined, I'm going to take the bottom and set it equal to 0 and solve for x. This is another AM method because, if you notice, it's a trinomial. Different signs, the factors of 6 that add to -1 are 3 and 2. So that being said, x cannot be -2 and x cannot be 3 in this question because it would make the whole fraction undefined. Now, this is actually very helpful because I already factored the bottom now into +2 and x minus 3. So that's the bottom. The top is going to be a little bit more work because if you notice, there's a 2 here and there's no GCF that can be taken out. So I'm going to do 2 times 6, which is 12. And I'm going to think of factors of 12 that add to 7. So that'll be 3 and 4. So I'm going to have to use glasses in this case. So it'll become 2x squared plus 3x plus 4x plus 6. I can take out a GCF of x and be left with 2x plus 3. And I can take out a GCF of 2 and be left with 2x plus 3 again. So my top is now going to be, of my fraction, 2x plus 2, because that's these pieces, times 2x plus 3, all over x plus 2 times x minus 3. And if you look at the top and bottom, what cancels out are the x plus 2's, and you're left with a simplified fraction of 2x plus 3 over x minus 3.